I'm going to show you three devices. These are prototypes of the technology, which enables you to generate high voltage, high current, at basically DC with a slight frequency, around 5,000 hertz. And these devices will generate this electricity without the use of any fossil fuels or any power source of any kind that needs to be replenished. These devices have been in operation on and off for a number of months. This particular device here weighs about a pound and a half, and I'm going to energize it now. And how do you feel in the unit now that it's in operation?
Buzzing, vibration, slight noise.
Vibration.
Yeah, vibration.
Just nothing serious, kind of a slight gyroscopic effect in the air. The unit itself is size-wise, I think about 5 inches. The unit is dead exact at 6 inches. It's about 2 inches tall. About 3/4 of an inch thick. This is a voltage meter, which is automatic. The unit is putting out a fluctuating voltage. It's 121.8 volts, I believe. It's stabilized at 121.8. The voltage will vary between 110 and 145 volts in operation. So we know the voltage. Now let's discuss the current. This device is capable of putting out up to 5 amps of electric power at 100 volts. To show the current now in operation, we'll use a light over here. There's a lamp already lit. This is a 100-watt bulb in this lamp, if you want to show that. Now, a 100-watt light bulb at 100 volts would be 1 amp of power. So I'm now going to plug it directly over here, and voila. You have 1 amp of electrical power. Actually, more than 1 amp of electrical power at 127 volts powering this light bulb, which is extremely hot to touch. To follow this out, we have the unit itself. Wires straight over here to this lamp. Now, there's no battery in this lamp, obviously. Certainly no battery small enough to create this kind of electricity. However, I will now show a unit that is even smaller than the first unit. This unit is a little less than 4 inches. A little less than 4 inches. And it's a little less, it's about 1 inch and 3/4 tall. This one weighs about a pound. Activate the unit now. Let's measure the voltage again. This particular unit puts out about 100 volts, right around 100 volts, 100.8 volts. A little smaller. It'll vary between 95 and 115 volts generally. This is a 100-watt light bulb again. Obviously, it's a base receptacle. No possibility of any kind of batteries in here. And with the aid of these two alligator clips, voila! Oops. There you go. Another unit that is generating an amp of electrical current. Very, very, very slight vibration of the device. Lower current. There are physically no batteries capable of producing this much current at this voltage. It's obviously being generated by the devices themselves. These are inherently high voltage devices, and they only produce DC with a slight frequency of around 5,000 hertz. Let's go over here and look at the largest device that we have. This is the largest device that we have made so far. This particular device is measuring about 17 inches in diameter. It's about 3 inches, a little more than 3 inches in depth. Turn on the primary frequency, and now the secondary frequency. The unit is now in operation. There's also a slight vibration in this. However, a very interesting effect. Paul, if you'd like to touch that. Now, slide that back and forth with your hands.
Much less vibration in the small one.
Less vibration in the small one. Okay.
But it's a tingle. It's there.
Okay. What is it doing?
When you move it, it feels like you're pulling it across the washboard. It doesn't want to go.
Right. It resists movement.
One step at a time.
Exactly. Each time the frequency comes together, it appears to have an effect. It's like a gyroscope. Perfectly solid state device, no moving parts, just the vibration as the device is in operation. Let's measure the voltage. This gauge is set at 1,000 volts DC. The unit is putting out 830 volts DC. 830 volts direct current. That is enough to kill a man easily at the right current. To show you the current, we have set up these lamp bases here. They're just wired in series. Each one of these lamp bases is wired in series. No possibility of any kind of batteries or any kind of trip from these devices. These are brand new 100 watt light bulbs. You want to help take this out? I appreciate it. it's a hot bulb.
And one out of the lamp we were using.
This is the smaller bulb. I know there's one more I can get. Excuse me.
And each of them that's sitting here now is a 100 watt bulb.
I found another 100 watt light bulb. So we have 10 100 watt light bulbs. The unit is in operation. Now looking at the unit producing several amps of electric current. 870 volt DC system. The unit will power more than 10 100 watt light bulbs easily. And here, current gauge. Current gauge will measure the amount of current that's being produced inside the unit itself, inside the coil. With fluctuating voltage and current. 1.23 amps here. 1.23 amps at 870 volts is quite a bit of power. That would be at least 8 amps at 120 volts. These units can be used to power aircraft, ships, automobiles, homes. At the present time, the units develop quite a bit of heat, which also could be captured to produce additional electricity. These units could very easily replace atomic reactors for power generation. Quite warm. This is the basic equivalent of an electric heater. Yeah, we're looking at 100 times 10 is 1,000 watts of power. So this unit easily generated 1,000 watts of power, and I assure you, it would do that all day long.
I've heard that some people question whether there might not be a battery inside of these devices. Can you tell us about that?
Yes. I've shown this to multiple of engineers, and they never question whether there's a battery involved in this at all, simply because of the physical size of the unit. A battery capable of producing 1,000 watts of electric power would be quite large and quite heavy. A lead-acid battery capable of producing this much current for this period of time probably would be about 24 inches by 6 inches by 15 inches. High voltage batteries are very rare. They're very large and they're very heavy. If this were a battery, it would be an entirely new kind of battery and would be quite valuable simply based on the principles of being a battery. There are no batteries known today that have this performance for capable of lighting and putting out this much power. 1,000 watts like this is basically an electric heater here in operation is what it basically is.
And there are no batteries in the unit.
No batteries within the unit, no batteries in the base of any of these lamps. So it's quite a bit of power being produced by a device that is way too small to be a battery, or have batteries involved.
Thank you.
All right, we've made great progress in the technology since the first parts of the tape, which were filmed several months ago. One of the criticisms about the device was that it produced only DC at 5,000 hertz sine wave, and we have created an inverter which will take the high voltage DC and convert that into 120 volt 60 cycle sine wave to operate television sets and power appliances. First, this is another unit which we've made here. This unit is around 6 inches in diameter. It's right about 2 inches tall, and it is exactly an inch thick. This device weighs 12 ounces, and it certainly is a very elementary device. And the unit is now functioning. I'll show you the output of the device. This is a voltmeter set at 200 volts DC. See both the leads here on the voltmeter, and connect them directly, and the unit is putting out about 186 volts. Is that right, Michael?
Yes.
Can you read the voltmeter in the lens of the camera?
Sure can.
Okay, 186 volts. It will fluctuate a little bit, and the unit still vibrates, as have the other units in question. Give you an indication of the power this puts out. This is a 100 watt light bulb, the standard lamp. And we have the electricity here coming right out of the wall. Show you this, Michael. This is a conventional 100 watt light bulb. Can you see that in the lens?
Yes.
All right. And give you an indication of the power. We can light a 100 watt light bulb directly off the leads. That is certainly as bright as it was in the lamp there. You're talking about at least 1 amp of power. 100 watt light bulb, which is getting quite warm. And for those of you who think that there is a direct magnetic coupling from something under the table to on top, we're going to move this device over here, certainly far away from the table, and repeat the same. There you go. 100 watt light bulb. Get that, Michael?
Yes.
Okay. And not only will it put out 100 watts to light a light bulb, but if we run it through the inverter, which is what we're going to do right now, you can see the device is connected directly to the inverter. The relay is closed. There's nothing going into the inverter. And television set, normal television set here. And I'd like you to come around, Michael, and show the back of this television set. This is a regular 120 volt television set. It says right here, AC 120 volts, 60 cycle, 1.2 amps of power. So there's no portable power in the television. I'm going to run the cord straight over to here, plug it directly in to the unit, and we have power. Coming through the inverter from this device. To show you the current output of the device. Remember the voltage before, you'll find that the voltage is only down a little bit. We're looking at, right now, it's at 170.5, so it's just down a little bit. Is that 171, is that right, Michael?
Yes.
171 volts even, and it will fluctuate just a little bit, but we're right around 171 volts. Okay. And we have our television set there. I will disconnect this device, show you that in fact the current is coming through the device. All right, now, to carry this a step further, let me put this back on. Okay, now the inverter is in function. This is an ordinary drill which has a 3 amp draw at 120 volts. 3 amps, 120 volts AC. We'll plug this into the inverter here now, and you'll find that it will operate a heavy appliance like this. 3 amps. This is a vacuum cleaner, which has an extremely, extremely high current draw when it is first turned on. There you go. Okay. Now, in case you think, yeah, we're still at our double output there, and we're going to take the device now and we're going to travel outside. You have to follow me in here. There's, again, with our same 100 watt light bulb. Watch your step there, Michael. Absolutely no magnetic coupling of any kind inside the home versus out here. We are a good 150 feet from where the original experiment was performed, and you will note that outside, again, we're looking at our 100 watts of electric power outside, a good 150 feet away from where the experiment was performed. It does get very hot. We'll return now, show you that, see, there can be no high current, there can be no close coupling through a high magnetic field. The unit would not operate outside. Device turned on again, and the unit is still operating. The television is in operation through the inverter. I want you to come over here, Michael, and get a look at the inverter so people can see. Oops, sorry. I seem to be making little mistakes here with this. I'm not really a filmmaker, just doing my best here. But anyway, the sound you hear is a relay closing inside of the unit. If you take a look on the side of this, you can see in there very well. This is the major relay which produces the sound. This is part of the converter circuit here, which takes the 12-volt direct current, 5,000 cycle output, and through the use of the resistors and so forth, and then this major conversion transformer produces the 120-volt sine wave, the 120-volt 60-cycle sine wave that is necessary to operate appliances. Obviously, the unit produces a minimum of 3 amps, but once it's gone through the inefficiency of the converter or the inverter, so it more than likely is putting out 4 amps or so when we're using these devices. Also, the current draw of these devices when you first turn them on is probably significantly more than the 3 amp standard output that's coming from this unit. But there's nothing inside the inverter that could contribute to the creation of electricity, obviously. This unit is not receiving any kind of electromagnetic energy from anywhere. If you talk to a microwave engineer, he will tell you that a microwave dish or antenna capable of receiving this much current would probably be about 10 feet in diameter. So we obviously don't have any of those in here. No close coupling electromagnetically through the table or anything of that nature. The power is genuinely coming from this device. This is the device, and we have, there are patents issued on this device, and we are seeking probably about 100 more patents on the device and everything that it can and cannot do. Television set is still in operation from the unit. Just keep the going there. And I'll show this television here. TV is still on. Not sure what the picture is like. But we've operated a television set for you. We've operated a 3-amp electric drill, 120-volt drill. We've operated a vacuum cleaner for you. We have measured the voltage both on and off the converter circuit. Maybe I can find a better picture of something else. Well, the point is that it does operate, obviously. And the current output is enough to operate everything, including the addition of a 100-watt light bulb. Well, maybe not. Yes. There we go. And this thing does get very warm. The unit has been in operation so far for 11 minutes. And we're going to let it continue to go for a bit longer. The units in operation tend to generate a little bit of heat, and to prevent our electric tape from melting, we generally don't like it to get too hot. You can back off a little bit, Michael, to get everything here in the picture if you don't mind. This is rated at 3.5 amps continuous, so its draw will be more than that when it's first turned on. And you note this is 3 amps even, 120 volts, 60 cycle AC. You might want to. Now, if you speak to a battery engineer, someone who designs portable power systems using batteries, lead acid, or whatever, he will tell you that there are no high voltage, high current batteries available. A battery capable of operating this kind of equipment for this period of time would be considerably larger and would certainly last only a few minutes. Again, it cannot be picking up any kind of microwave or magnetic influence of any kind to operate the 100-watt light bulb and run the inverter and operate the television set. It would be highly unethical to do anything of that nature. If you ask engineers, generally speaking, they will respond by telling you that this kind of power is simply not available with any kind of a portable power supply. The draw on the television set is 1.2 amps at 120 volts. The output, by the way, from the inverter, I will show you that the output is that's the sine unit is different than the sine wave you would receive from a conventional wall socket. So it measures at 103, but in reality it's the voltage that the appliance sees is probably over 120 volts actually. The unit has now been in continuous operation for 14 minutes. Are you getting everything in the picture? I mean, just the three pieces here. These units can operate while you are traveling in an automobile. We have taken this unit in an automobile and driven miles and miles and miles, and still operated equipment at any destination or in the automobile while it's traveling. We've operated the 100, 200 watt light bulbs from the unit for extended periods of time while we were in motion. The units have been tested in aircraft. They produce very slight variances in output in the air, but generally don't affect the operation of the aircraft in any way. And they do perform well, at least at an altitude of 15,000 feet. The units are not dependent on being close to the ground. They're no longer dependent on their attitude in any way in regard to the horizon. They simply produce a great amount of electric power. We can operate these devices through a variety of other inverters. Initially, the devices were designed and they were frequency sensitive, and they're still frequency sensitive. But with the use of the trip light inverter, we've been able to power appliances now. And you've seen the beginning of this tape the operation of 1,000 watts of power, basically, the 10 light bulbs from the larger unit. This unit is 12 ounces. Don't have a scale here, or I would measure it for you, but the basic size of the unit at 12 ounces and the weight of the unit at 12 ounces and size at 6 inches and so forth. Very compact. This particular unit is capable of putting out up to 7 amps. It needs the use of a heat sink for continuous operation at 7 amps. But 7 amps of continuous DC output is more than enough to create a marvelous portable prime mover type of power, as in an electric automobile. You could easily create an electric car using these kinds of power supplies here. This technology basically makes batteries obsolete. There would be no reason to have a battery to power an automobile or anything like that. You could use these devices. We have made larger devices which put out an average of 20 amps of current at 1,000 volts. These devices could easily power large industries in third world nations. Could even power aircraft without the use of fossil fuel, whatever it might have to be. And the basic point to all of this is that this is a new technology. It's an entirely new way of doing things. It is not a battery. It is not collecting energy from outer space. In fact, the technology utilized in this is very simple. Receiving old standard engineering philosophies. This is nothing magic. This is not a technology which is basically the equivalent of perpetual motion. It is not that at all. The power comes from a very viable source that we use every day, electromagnetic fields. The use of electromagnetism, or the use of a magnetic field to create electron flow in a wire has been around for hundreds of years, and it's what we use every day. And basically that's what we're doing here. We are creating electron flow in wire. This device has the ability to produce power probably for every application that we have now today that utilizes batteries. This would replace, I would think, almost everything. It is possible to utilize several of these units to create probably thousands of amps of current, if necessary. You notice that the device has been in operation for 20 solid minutes now. There basically is no heat that's too substantial from this unit now. Nothing too difficult. And I will, for one final time, measure the voltage output from this unit, so that you see it has not dropped significantly as it would if it were a battery. See, when you use batteries for a period of time, they go down a lot. And in this case, we're looking at 169.1. We were at 170 volts 20 minutes ago. We're now at 169.2. So it's dropped just a little bit, but quite obviously it certainly has not dropped significantly, as it would in the case of if it were a battery powering it. And the basic point is there are no batteries on the planet. There is no battery technology. There is no energy storage technology that could possibly equal the size and weight of this device and its creation of high current, high voltage electricity. Absolutely impossible. Thank you for your time. I could let the unit continue to operate for quite a period of time, but it's been on now for 21 minutes, and I think we have well proven the point that this little 12-ounce device is the power system. It's putting out at least, running through the inefficient converter going to the TV, it's probably putting out a 2 amps of power or so, and definitely operating the television set. So I'm going to turn the unit off for right now, and I'll make another tape very soon, I hope. So thank you very much for your time and your 22 minutes of time. Thank you. Should shut it off now, Michael.
How do you push the button?